Alright, so um, in the last video we got done with our entire API, and now it's time for annotation processor. What we're going to do in the processor is basically we're going to create classes that will extend um, each of our mocks so that we can assign them to our mocks. But within their methods, their respective methods, these are the methods that this class has. But obviously in the mocks, whatever logic you have won't be there because they're mocks. They're not supposed to, call the actual. Um, uh, they're not supposed to perform the actual logic that comes with the class itself. They're supposed to just let you know that they're called, or they're supposed to return whatever value you want them to return. So our annotation process will pump out new classes for each of our mocks. It will also pump out a class that's going to initialize our mocks for each test class. It's also going to pump out initializers for each test class. So, so let's do that. Let's go to our. We had created our processor in the first video, so we're just going to build on that. First of all, we want to. Each abstract processor has two methods that you need to also extend. One of them lets the compiler know which annotations that we're interested in. The other one is about the source version. So get support of source version and get annotation types. We're gonna do this. This is going to return set of our mock canonical name. And we're going to leave this one as it is. We're not going to do anything there. So yeah, let's go and start doing things. This is where we're going to be using the Java Poet a lot that I mentioned. So let's just start coding. We're going to keep a set with every single one of our test classes. So we have this one right now. When the annotation processor kicks in, this set would contain that. And if you had more test classes here, this would also contain that. Here, we're creating a map from element to a set of elements. What this is that the elements here are the same, but the set of elements they're pointing to are basically the mock fields. So let's do another example of this. Right. Let's say this time return, I don't know, object, get the thing. Right, and the parameter into a, whatever, return null. Right, so we have this class as well. Let's add that here. So what's going to happen here is that this one will have two elements, one for each of these classes, and the other one, this one will have element will be the test class mock test, and the sets that it's pointing to will be these two. Does that make sense? So it's going to map each of the test classes to the mocks that they contain. Now we're going to create another one. I'm going to explain what these do. This is method UID is every single one of the methods that our mocks have combined. Like I said, each of our mocks will end up each of the methods within our mocks will end up having a unique ID, and we're gonna add them all into that set. And in this case, for instance, this class will have two methods, so two UIDs here and another one here. So this one will contain three unique IDs. And this is basically for each element, each field here. It's going to map that to their constructors. It's also going to make more sense as we start doing more. Oh, forgot a huge step here. This gives you all of the elements that are annotated with your particular mock. In this case, it's going to return all of everything that's be annotated. So the way these work is that when you get the enclosing element, for instance, you go here, the element is this, enclosing element is mock test. You know, because if the element you have points to the mock test and you get enclosed elements, I mean you call enclosed elements, then you get a list of elements within it. But if you're on one of these, if your element points at one of these and you call enclosing element, then you end up getting the one that's that it's contained in. So here, this is the test class. So we're going to add that to test classes. Initializing it if it's closed. I mean, if it's empty. And then we're going to add that. So what we did here so far is that we initialized the key values for the test class field map, and then for the enclosing type, we added the element to it. So for this element, we get the type, so we can use that type in other places, and then from there we got the element, and that's gonna help us for the type. We got the element. Elements can represent many things, such as fields, types, and methods, anything. So this type element is the type for the given field. So if you look at this, the initial element contains data about this field, but to get the type of that field, then you get the element that's pointing to the type class. And that's what we did there. So now we're going to actually create our mock class. And this type spec, it comes with Java Poet. guess we need to import that. Alright, cool. Okay, so let's quickly test it out with something very small, which is what we have right now, and it'll make sense. Um, this is the code that we're going to use to. Yeah, I just copy pasted because this is just boilerplate code that pumps out the class. So if you go back here, and if you run this, yep. So our annotation process worked, and how do we know that? Because it pumped out the class. If you look at our here, not here, generated annotation processor test, you see for each one of your classes, it pumped out these classes. For each one of our mocks, it pumped out these mock classes. So technically speaking, these are available in your class path, and you can do this. See, obviously we're not going to do this manually. We're going to have more classes available um, that are going to do that for us. So let's go back to, obviously this is also going to not compile because we have an interface, and we have to have those methods be implemented. So we have a lot of work to do. Well, let's just get to work. So here now we're going to the field type element, um, which is basically our methods. Well, it's going to have all the fields for the mock class too, but we're only interested in methods. So we're going to check. We're only going to do what we do if it's a method. So we're not interested in anything that's not a method. So for each of our methods, like I said, we're going to create a unique ID. And Java has a library that does that. So we're going to use that. And then we're going to add that to our list of method UIDs. And so we're going to cast this element to executable element. Executable element will contain more information in regards to our method. Now that we know its kind, it's just a method, we need access to all of the methods, all of the data that comes with it, such as parameters and stuff. So we know the return type. Obviously, the return type can be void, which is fair, which is like perfectly acceptable return type. This is just, we're going to use this params thing later in many places when we decide if what we return is going to have parameters or if it's just null. So now we're going to add the same methods to our mock, so we can call them. So let's run this, see what it is. Oh, it does do it because we didn't add the method there. So let's just do that. Our method's not done, but I just want to show you what we're doing here. So our mock has now the exact same methods that our base classes have. So, and we're on the right track. And we're setting the invocation for each call that we create in our API. And so our API know when a method is being called, our API knows that that method is being called on this mock that's given. How does it know which method is being called? Because each method has a unique ID. But obviously we're not at all done here. So now we're going to add in a way, um, means to verify invocations. Actually, I'm going to cut it here, and let's do that in the next video because these videos get extremely long, and I feel like they're not consumable enough. So I'm going to cut this one here, and we'll do the next in the next video. Thank you for watching.